Hello everyone. Today we will study about this topic. First, we will study distance of a point from a line and a plane. Okay. And secondly, we will study the distance of two lines and two planes, like two parallel lines actually. Okay. Third, we will study image and the foot of perpendicular of a point with respect to a line and a plane. One by one, we will discuss each and everything with the sequentially in this order. So, as we have listed here, first we will study distance of a point from a line and a plane. Distance of a point from a line and plane. So before going to distance, let's say we'll write the general equation of line. Ax plus by plus c equal to 0. As we know, this is the general equation of line, and general equation of plane is ax plus by plus cz plus d equal to 0. This is general equation of line, and this is general equation of plane. According to the question, the distance of a point from a line and a plane. First, we'll study that the distance of a point from a line. So the line given ax plus by plus c equal to 0, and there is a point x1 y1 e point, and we need to find the distance pm. So in this video we are not going to prove this how it's can, but we will go just directly to the formula. What we can do is satisfy this point p into the line ax1 plus by1 plus c modulus divided by a square plus b square under root. This will be the distance of a line from a point. Similarly, if we want to know the distance of a plane, this is the plane from a point x1 y1. Suppose the equation of this plane is ax plus by plus cz plus t equal to 0. So in this case also, pm distance will be, just satisfy this point into the plane ax1 plus by1 plus c z1 plus d. Suppose this there is another coordinate z1 divided by a square plus b square plus c square under root. These are the perpendicular distance of a line from a point. In these two cases, there is a special case. Special case, or we can say the point is just origin 0, 0. So distance of a point from origin, if there is a line, find the distance from 0, 0 from the line given ax plus by plus c equal to 0. So here pm will be, if we satisfy this point 0, a, 0 into a plus 0 into b plus c modulus divided by a square plus b square under root. So all the terms will be cancelled out 0, 0, and only constant term will be remain a square plus b square under root. This is the distance of a point from a line, distance of origin from a line. Similarly, if we go for the distance of a plane from origin 0, 0, 0, so here pm will be constant term divided by a square plus b square plus c square under root. The equation of ax plus by plus cz plus d equal to 0. This is the distance of a line, distance of a point from a line, and this first part is completed. Second, we'll go distance of two lines and two planes. Second is thing distance of two line and two plane. Here, line and plane in a sense two parallel lines. Suppose a there is a one line and there is another line. If two lines are parallel, if the equation of ax plus by plus c equal to 0 of this line, then the second line equation must be ax plus by. All the x and y terms should be same plus d equal to 0, or should be in the same ratio. Like if we say there is a line L1, there is line L2, a1x plus b1y plus c1 equal to 0. There is another line a2x plus b2y plus c2 equal to 0. So L1 parallel to L2, so there must be a1 by a2 equal to b1 by b2. This case is for parallel. And if we add c1 by c2, this all threes are same, then these two lines are coincident. Okay? So let's not go to the not going to this part. We'll just study the distance between two lines. If the distance between two lines is, we can say the point P and M, then PM will be just the difference of the constant term divided by a square plus b square under root. In similar way, if we go for two planes are parallel. So this must be ax plus by plus cz plus d equal to 0, and this must be ax plus by plus cz plus e equal to 0. As we have seen that all the xy terms should be same. Similarly, in the plane also, to be parallel, the xy terms should be same. So in this case, pm will be same. The difference between the constant terms e minus d or d minus e, as we will be use modulus, so that's a no point. A square plus b square plus c square under root. Okay, that's if you use some question है कि find distance from origin and 3 and 6 from a given line 4x plus 3y plus 5 equal to 0. Suppose there is a line 4x plus 3y plus 5 equal to 0. There is a point 3 comma 6. So we need to find the perpendicular distance pm. Pm will be satisfy the point P into the line 4 into 3 plus 3 into 6 plus 5 modulus divided by 4 square plus 3 square under root 12, 18, 5 modulus divided by 5, 35 divided by 5 and 7 unit. And if it distance from origin, the distance from origin will be constant term divided by a square plus b square under root. Constant term here is 5 divided by 3 square plus 4 square under root 5 by 5 in 1 unit. So these are the two concepts we have listed here. Though the distance of a point from a line and distance of a two line and two planes, actually parallel planes, are completed. So we will go for the third, the image and foot of perpendicular of a point with respect to a line and a plane. So third of the sequences, sorry. So third point of our lecture is that the image and foot of perpendicular with respect to a line and a plane given. Suppose करो कि there is a line x plus by plus c equal to 0. There is a point x1 y1. I need to find the foot of perpendicular, the perpendicular point from a line. If you draw perpendicular from a line x1 y1 to a line uh, x plus by plus c equal to 0, so where it will be meet? Suppose this will meet at x2 comma y2. So I need to find this point x2 y2. How we can find the point? As we know that if you the point M is x2 y2, the point P is x1 y1, the slope of 2 point we can find like difference of y2 and difference of x2, y2 minus y1 upon x2 minus x1, and slope of line minus a by b. So we can say this is if m1, this is m2. So m1 m2 will be minus 1. As these two lines are perpendicular, then the product of their slope will be minus 1. Then y2 minus y1 upon x2 minus x1 into minus a by b will be minus 1. Minus minus gone. So from here we can say x2 minus x1 by a equal to y2 minus y1 by b. Let's say these two values are equal to lambda. So we can say is x2 equal to a lambda plus x1 and y2 will be b lambda plus y1. Anyhow, we have to find the value of lambda. So we can say that x2 y2 is the coordinate on the line L1. If we say this is line L. So what we can do is that we will solve these 2 points with the line ax plus by plus c equal to 0. Okay. So um, x2 y2 satisfy line given. So that's if we satisfy this line, what will be given? That's x2 is equal to a time a lambda plus x1 plus b time b lambda plus y1 plus c equal to 0. From here, we can find the value of lambda is minus of ax1 plus by1 plus c divided by a square plus b square. So we will put this lambda value in equation 1 directly here. So from here what we can get is x2 minus x1 divided by a equal to y2 minus y1 divided by b equal to lambda. Lambda is nothing but minus of ax1 plus by1 plus c divided by a square plus b square. For lambda, just satisfy the point which I have to find image and the foot of perpendicular. Satisfy with the line and divided by a square plus b square. This is the formula for foot of perpendicular. See, the line, this is foot of perpendicular x2 y2. This is our point x1 y1, and there is another point x3 y3, which is image of x1 y1 with respect to the line L. So we can say this x2 y2 will be the midpoint of x1 and x1 y1 and x3 y3. So we can say that x3 minus x1 by 2 will be x2, y3 minus y1 by 2 will be y2. In the similar way, if we solve this two line with the equation given, so in that case x3 minus x1 by a will be y3 minus y1 by b equal to negative 2 times ax1 plus by1 plus c divided by a square plus b square. So this is the formula for the image. Let's wind it up here. The line ax plus by plus c equal to 0. The point given x1 y1. We need to find x2 y2 and x3 y3. X3 y3 is the image and q. So from this equation, from this line, we can say formula is for foot of perpendicular x2 minus x1 by a equal to y2 minus y1 by b equal to negative times satisfy the point x1 y1 into the line ax1 plus by1 plus c divided by a square plus b square. For image, the coordinate of image is x3 and y3. So x3 is with respect to x1, x3 minus x1 divided by a equal to y3 minus y1 divided by b equal to. So for foot of perpendicular, we will use here 1 or negative 1. For image, we will use minus 2 ax1 plus by1 plus c divided by a square plus b square. Okay? In the similar way, if we see the if we see to find the point, if we see to find the point in the plane, let's use the red color. Let's. This is the equation. This is a plane. There is a point x1 y1 and z1, x2 y2 and z2 on the line on the plane, and x3 y3 z3 will be image p q r says. So the equation of this plane is ax plus by plus cz plus d equal to 0. So how we can find same concept goes like we have used in line foot of perpendicular के लिए it's x2 minus x1 by a, y2 minus y1 by b. Here we will add z2 minus z1 by c equal to same. We will put this point into the plane with the negative sign ax1 plus by1 plus, or we can say we can write here negative of ax1 plus by1 plus c z1 plus d divided by a square plus b square plus c square, not under directly. And for image x3 minus x1 by a equal to y3 minus y1 by b equal to z3 minus z1 by C is equal to, based on the plane and the point, we'll use a questions. That's the question says, find length, image, and foot of perpendicular of point 7, 14, and 5 with respect to plane 2x plus 4y minus z minus 2 equal to 0. So there is a plane 2x plus 4y minus z minus 2 equal to 0. There is a point 7, 14, and 5. I need to find the distance, the length pm, and coordinate of m and coordinate of n image. So for length pm, we will satisfy this point into the plane with the modulus sign, like 2 into 7 plus 4 into 14 minus 5 minus 2 modulus divided by 2 square a square plus b square 4 square plus c square, which is minus 1 ka whole square under root. So on solving this, we will get 63 by square root of 21. This is the distance pm. If we want to find the foot of perpendicular, like is, if we say x2, y2, and z2. So x2 minus 7 divided by a, nothing but 2. Y2 minus 14 divided by b, which is 4. And z2 minus 5 divided by c, which is minus 1, equal to negative of the point we will satisfy on the plane, minus 2 into 7 plus 4 into 14 minus 5 minus 2 divided by a square plus b square plus c square, which is 2 square plus 4 square plus negative 1 ka whole square. So from there we will find negative 63 divided by 21, which is minus 3. So we can say is x2 minus 7 by 2 equal to y2 minus 14 by 4 equal to z2 minus 5 by negative 1 equal to minus 3. So from there we'll find x2, y2, z2. See, 2 into negative 3 minus 6, minus 6 plus 7, which will be 1. So x2 will be 1. And 4 into minus 3 minus 12, minus 12 plus 14, which will be 2. So y2 will be 2. And for z3, minus 1 into minus 3, 3 plus 5, which will 8. So 8. So image we find 1, 2, and 8. Sorry, put a perpendicular we will find 1, 2, and 8. 1, 2, and 8. And it's your work to find the image. Okay.